Let me get rid of one second, please. Okay, can you see my screen now? All right, so this is not going to be a slides kind of presentation. It's going to be entirely a live coding session. So I'll be using Colab. I'm guessing most of the folks here should be familiar with Colab. If you're not, it is just a online environment for executing Python code, free to use, and you can get access to some relatively beefy GPUs if it is one of your lucky days. That's pretty hard to come by. One thing I want to note is that for this to run, you'll have to use, or I've only tested the Colab on this particular runtime, which is the A100. The other ones, it may or may not offer it. I know for some of the smaller ones, you won't be able to do everything at the same time. You may have to split into different environments, but because I want to keep this relatively concise, it's all going to run into a single Colab instance. So I already have some code here, so it's not completely from scratch, but this is just some boilerplate stuff. So first, I'm going to install the dependencies, which is just Keras and Keras Hub. They may or may not already be installed in Colab, but I want to make sure they are on the latest version. So let run. And then what I'm doing here is signing into my Kaggle account. And I can do that in multiple ways. I'm taking the easy way out here and just setting up some environment variables for my secrets that are managed in my Colab instance. It's actually a pretty common workflow within Google. And I actually do recommend it if you routinely use Colab. So let me send that in. Okay, and now I'm entirely on my own, and we're going to start the fun here. So first, let me import the Keras package. I'm going to import Keras Hub as well. And before I run this step, actually, let me just do a little bit of an overview of what we're going to do here. So within this session, we are going to create live translation service that should be run or should be able to run completely offline. Now, obviously, I'm presenting here online. Typically, when I do this presentation elsewhere, I do this flashy thing where I turn off my laptop's Wi-Fi. If I do that here, then we'll lose connection, and that will be a lot less fun. So we're going to keep it online. But once the models are downloaded locally, all of what I'm going to show you should be runnable completely offline. I also want to note that machine translation is a very niche specific topic, but in the context of science, I just want to show you the, my opinion, pretty amazing power that you can garner, gather from simply existing open models. I'll be using Gemma 2 and PaliGemma, which at this point are probably close to a year old, which in AI years is what, 14 years. So I'm importing Keras now. And now what I'm going to do is, because I have an environment with relatively limited GPU, I'm going to set the precision to half float. So I'm going to do Keras config set float x to b float 60. I don't want to go into too much detail about what this means, just saying that I'm reducing the precision without too much loss of actual performance. This is going to take about a minute. Okay, and now I'm going to load the actual language model. So let's call it LM. I'm going to say Keras Hub, models, Gemma, console, LM, there it is, from preset. And here I'm simply going to download the weights using Kaggle. This is why I needed to have my Kaggle account set up. And we're going to download the instruct 2B English. This is the smallest model. That's it, right? This is the smallest model from the Gemma 2 family that is currently available. It is 2 billion parameters. I think that works out to about 4 gigs of actual RAM usage. So now it's probably downloading the model and loading it into RAM. And probably see the GPU RAM starting to spike now. Should take about a minute at most. It's relatively quick. Okay, and that's done. Let's see if we actually have the model running. So let's do a test. Let's do lm generate what is the capital of France. And then one thing I recommend is that you always set the max length, because some of these models can be quite verbose and they go on a bit of a tangent. So by setting a max length, I ensure that it doesn't go on for too long. Sure, I'm happy to make the notebook public and just share the link. The first generation typically takes a little bit longer. Subsequent generations are normally much faster. So something to keep in mind if you're building an actual application. Can I use my Google Cloud account to technically, oh, my session crashed. That's interesting. Okay, it's restarting. I used all available RAM. There you go. Okay, let me double check that I have the right setup here. So I have, yeah, this should be the right one. So let's just start again. Sorry, this is going to take about a minute. I'll look at the question in the meantime. If you can use Google Cloud to create a runtime for this notebook, yes, absolutely. That'll be the Colab Enterprise version. Just make sure that you use a big enough GPU so you don't get the issue that I just got, which is that I ran out of memory. So let's see if the second run we get a little bit luckier. Like I said, this can be a little bit temperamental. Sometimes it's a matter of you get the good GPU or the bad GPU, or maybe it's because I had previously or had kept that window open for a little while and Colab eventually just evicted my resources. So let's see if we can get the generation to work. If this fails again, it probably means that the max length that I set here is just too long, because the longer the context window, the more memory that it uses. So if this fails again, we'll just shorten the max length and see what happens. Okay, so it worked. So we have what's capital of France. Capital of France is Paris, end of term. So that seems pretty reasonable. That tells me that the relatively small language model is working well. So now how do we go around building a translation service? When it comes to some of these models, it can be as simple as asking the model to translate. So let's do a bit of an exercise first to build a prompt for how we're going to do the translation. So let me start by defining a function, and let's call that translate, because I am very original. And we're going to start with language origin, language destination, and then which text we're going to translate. And this is going to output a string. And let's create a prompt. So for the prompt, let's start with something very basic. Let's say translate the following from line source to line destination. Now, like I said, some of these models can get pretty verbose. So let's try to prevent that and actually provide specific instructions to say output only the translated text without any explanations. And before I even do anything else, let's just output the prompt just to see what this is going to look like. So let's do a test. Let's see translate from English to French, hello world. Okay, so that seems somewhat reasonable. What we do now is, now that we have the prompt, we are going to feed it to the language model. And we're going to do output equals to lm generate prompt. Again, don't forget to set the max length, otherwise this can get pretty unwieldy. And then one thing I also recommend doing in this instance is, I don't want my prompt to be part of the output, because I don't care about that. I already know what the prompt is. It's a very handy function, or a very handy option called strip prompt. You set it to true, and that way you don't even have to do any kind of post-processing on the output. And let's return the output. Let's see what happens now. Okay, so this is, again, it went off the deep end. This doesn't make much sense, right? So it's getting some French stuff here, but this is not quite what I was looking for. So this tells me that I need to be a little more forceful when it comes to guiding the model. This is going to be entirely dependent on which specific model you're using. And even within the models, there are obviously different variants. What I'm going to show here is going to work for this model. It may not work for other models. It actually may be counterproductive for other models. Also, I want to note that what I'm going to do here, it is very hacky and very demo worthy, but please do not do this for production purposes. So I'm going to use some HTML-like tags to steer the model into outputting just what I want. And I'll type it first, and then I'll explain what I'm doing. So first I do this origin language tag-like thing, and then I'm going to open the tag for the destination language. And before I generate the output, I'm just going to output the prompt so we can see what's happening. And then it's just to output, and we're going to print it. So what I'm doing is, I have my, let's call it preamble, and then I have these tags that indicate which language I have this text in, and then I open the tag for the language that I want the destination language to be in. My expectation now is that the model will be a lot more keen to simply output the translation for this here, followed by the closing tag. That means that we'll probably have to do some slight post-processing of the output, but we'll get there in a second. Let's just try to run this and see what happens. Let's say just hello for now. Okay, so we have bonjour as the first word, and then again, it goes somewhere on a rant thinking that I want to translate more things, but I want to prevent that. So a very simple way to do that is to simply snip off anything after that first closing tag. So this is going to be a little bit of post-processing, and this is the part that I mean that I was referring to when I said this is pretty hacky. So it's going to work for the demo, but it is relatively brittle when it comes to production services. So we're going to split the output based on the closing tag. And we're going to grab just whatever comes first. And let's see what it looks like now. Okay, so now we have the output relatively clean, going from hello in English to French. Can we go the other way around? So let me just copy this. And we go from French to English. Okay, so at the very least, it is self-consistent. Now, one of the things that I particularly like about Gemma is that it has been trained on a very large corpus of text from many different languages, including those that are not from the Romanic languages. So let me give you an example. How do we say hello in Korean? Now, let me be very clear here. I do not speak a lick of Korean. So how do we know if this is correct? Well, at the very least, we can actually check if it's self-consistent. So let's do the same trick. And we can actually, let's do it in a different cell. And let's translate from Korean to English. Let's do this. And let's print the output. Okay, so at the very least, it's self-consistent. Actually, let's go one step further. Can we go from Korean to French? Okay, so far so good. So as simple as this, we are able to build a text-based system that seems to work relatively well for translating at the very least simple words. Keep in mind, this is the smallest possible model we can find for Gemma. There are 9 billion parameter models and 27 billion parameter models. Those are expected to perform significantly better for most tasks, including machine translation. But this is pretty cool. However, we want to take this one step further. Now what I'm going to do is to introduce a vision model into the mix. And the end goal is to have a picture or an image of some kind of text, and then perform a translation, first by transcribing the text from the image to some kind of text-based format. And then from that text, we can do the translation that we've already performed here. So let's start by loading the vision model. Let's do VM for vision model. And I'm going to use PaliGemma. Also LM preset. I think it's PaliGemma. Let's see if I can get this right. And we're going to use also the smallest one. 2 to 4 means that it is 224 pixels. First try. Okay. So that's going to have to load the model. This can take about a minute. In the meantime, do we have any questions on the chat? Okay, so far so good.
By the way, I just added everyone on the call because it's a small group. I made everyone a contributor, so anyone can feel free to just come off mute and ask questions. It's a very manageable group today, so feel free.
Perfect. Okay, that was pretty fast. Actually, this is one of my biggest frustrations with Colab, that every now and then, you can restart your instance and suddenly networking is 1/10 the speed. It's just luck of the draw, whether you get a machine that happens to be co-located with where the models are cached, or you get a machine that is very far away. We got lucky this time, and it took a minute, but playing with these other times, sometimes it can take 5 or even 10 minutes to download some of these models. So now we have loaded the vision model. But before we start using it, let me see if I can pull the image that I was playing with. So I have an image here, a URL being this, and let's display it so we see what we're working with. So this is just some pretty standard Python stuff. I don't want to get too much into it. I'm simply going to download the image and load it into the notebook. I'm going to use the pillow package to load the image. So I'm going to load into buffer, into byte buffer, and we do HTTP X get that, read the content, and then the image is going to be image, open the buffer, and let's see if I got this right. Let's see what the image looks like. Okay, so that is my image. It is from Wikipedia, and it is some kind of sign in what looks to be Korean to me. I can kind of guess what the sign means, but obviously I don't understand what any of the symbols mean. So let's try to see if we can use AI to come to the rescue here. Let me clear the output because this is pretty big. Okay, so now we're going to use the vision model. So let me create a different function here, and let's call it OCR translate. And we're going to start again from an origin language, destination language. But now the input, instead of being text, is going to be an image. And we're going to use the pillow image format. And this is going to output some kind of string. So like I said, the model uses 224 pixels as the format. There are other models that I think is double the size, so it's 448. This is just the smallest one. So the first thing we need to do is to ensure that the image is in the right format. There are many different ways to resize the image. You can do some kind of cropping. You can deal with aspect resolution. Here we're going to do the lazy thing and just fit everything into a square of 224 by 224 pixels. Then another thing you need to keep in mind is that these models have been trained with images that have 3 channels. Some images, like the PNG format, may have an alpha channel. I think some formats of JPEG may have an alpha channel too, but I may be misremembering. So just in case, we're going to reformat the image first as a NumPy array. So we have to import NumPy. And then we're going to remove the last channel. I'll show you how in a second. So we do image, and let's do NumPy as array, image. Now, pillow image formats are actually in typically floating point, unless you set the different flags. I am not super familiar with pillow, so instead I'm going to do this in NumPy. So I'm simply going to multiply the image by 255. That means that I'm going to convert this into uint format. Let's type uint. And now I'm going to remove everything but the first 3 channels. Okay. And now let's just output the image for now to see how this works. Return image. And let's see if we get this right. OCR, translate. And let's go. We know it's from Korean, English. And let's just use the image that we've already loaded. And look at that. We already have our in the array 224 by 224 by the 3 channels. The colors don't look quite right, but I actually don't. Let's see, did I get this wrong? So let's remove that for a second. Yeah, so I think it's just probably a display issue. Even if it's not a display issue, I can clearly read the characters, so this is not going to affect the final result. But this is a demo. This is not going to be a production service. This may have an effect if you're trying to build something a little more robust. So we have the image. Now what we need to do is to call the vision model. The vision model is very similar to, it follows a very similar pattern to the text model. You call the generate function. But in this case, you have 2 components as inputs. You're going to have your input image, but you also need some kind of text prompt that is going to ask the model to do something with the image. So we actually have inputs is going to be a dictionary. Images can be a collection of images or just a single image. And then prompts can be the same. And all of my prompt is a single word, OCR. OCR stands for optical character recognition. So all I'm asking PaliGemma to do is to transliterate or transcribe whatever is in the image into textual format. And then I'm going to play the same trick as earlier and do the strip prompt to true. And let's just return the output for now. Let's see what happens. depending on your model and your GPU, this can be relatively slow. This is not nearly as optimized as some of the language models. Okay, so we have some kind of text here. I find this really, really funny. And not only did it transcribe the actual characters, but even the upward arrow. I don't know, I'm just personally very amused by that fact. But it is able to do something that looks reasonable. I don't have the image here in front right now, but these characters look pretty similar to me. So let's move forward and see what happens. So first, one thing I want to point out is that it's going to go line by line. Now, rather than feeding everything in one go to my translating function, I'm going to split into different lines, and I'm going to translate one line at a time. So instead of a string, actually, we're going to output a list of strings. And let's do for line in output split in the new line. We are going to well, first skip any empty lines. I don't think I have any, but just in case. If not, line, continue. Then I'm going to translate using my translate function from earlier. And I'm going to pass through whatever my origin and destination languages were. But now I have the line as the text. And I am going to collect the output into a callback into an array. This is still array. Actually, even better, rather than just appending the translated, or you know what? Instead of outputting a list, I'm just going to print the output. Let's keep this simple for now. So we're going to do print, and I want to see the original line. And let's do space in between, and then let's print the translated version. So all I've done here is basically hook up my vision model into my existing translate function. That let me scroll up really quick. I defined here, and just to refresh your memory, all I'm doing is outputting the translation of the text from origin language to destination language with a little bit of post-processing afterwards. So like here, we can translate our image from Korean to English. That was actually pretty fast. Like I said, I think it's really cute that it even has the up arrow, and go figure, the up arrow is the same in English and in Korean. Like I said, I don't speak Korean, but based on the image, and I'll display it again, it seems reasonable to assume that this means one-way traffic. Now, I checked just before the talk today, and according to Google Lens, this actually means one-way street. I'm guessing that there's probably a little bit of leeway when it comes to the translation, and this in English would typically say one-way street as opposed to one-way traffic. But this seems like a reasonable translation. Like I said, I don't speak Korean, and like I also said earlier, this is the smallest model, both for the vision as well as the text models, that you can get your hands on right now for Gemma. So it only gets better from here. So it is 10:35. It's almost on the dot of 30 minutes. We have built somewhat performant, reasonable-looking real-time translation service that should also work offline, leveraging exclusively open models. I think that's pretty amazing. So I would like to open the floor now for any questions, or if you have an image that you want me to translate from one language to another. I think we're up for the challenge here and see how it does.
Hi. So I got a question. So like in the example given, it's mostly natural language to natural language translation or image to natural language translation. Is it possible to do like a natural language to like context-free grammar languages like SQL or something?
So
Like
going from natural language.
Oh.
Sorry, let me refresh to see if I understand. So going from natural language to say SQL.
Yeah. Like it follows a certain kind of structure.
I wouldn't say that's the typical case for machine translation. I don't think that's necessarily translation. That's more of instruction following. In the same way that you have these models that are able to convert a collection of instructions to code, that's not what's traditionally considered machine translation. You can absolutely do it, but it will not be with this prompt right here. You're going to have a different prompt. So it is doable, but you're going to need a different prompt, and B, potentially different model. I would actually recommend using something like Code Gemma that has been specifically fine-tuned for coding tasks, as opposed to the base Gemma, which is more for general purpose.
Right. But like, what if what if I created a new language using context-free grammar? Like, is it possible to feed the grammar to the model and let it know like what kind of language to translate to?
Depending on how big your definition of the grammar is, if you can stuff it all into the context, then great. Otherwise, you may be better off using your own fine-tuned version of Gemma or some other open model. You can certainly do that efficiently with some pretty standard techniques like LoRa. We actually have a collab for how to fine-tune Gemma using LoRa on Colab. I think it takes less than 30 minutes to run, even with the free GPUs that you can get on Colab. So it is definitely doable, but you probably have to go a little bit beyond just prompt tuning.
Hi, my name is Erica. I was wondering how much computing power would you need to run larger models? What would you recommend?
More than computing power, what you need is bigger. The bottleneck for some of these bigger models is mostly around the amount of RAM or the amount of memory that these GPUs can hold. You can look at the different performance of different models. There's also a whole lot of tricks that you can play. Like here, I just said to have precision. You can probably go even further and use 8 bits instead of 16 bits. You're going to be trading off. There's a whole lot of trade-offs that you can have here. So it totally depends. Also depends on how much you depend on it being real time. So if you're willing to wait a few minutes, you don't even need a CPU, right? Or sorry, you don't even need a GPU, and you can actually run on CPU. As a matter of fact, I've done this demo before, and I ran it on an Apple Mac laptop. And at the time, we didn't have Keras running with acceleration, so you run it entirely in the CPU. So it takes maybe instead of 10 seconds, it takes 2 minutes per prompt, but it works, right? So it totally depends on which trade-offs you're willing to make. Sorry for the non-answer.
That's awesome. Thank you.
And while we keep getting more questions, let me actually share this with the group. Okay, great questions so far. Any more questions or anything that you want to discuss? Any potential ideas that come from this?
I've got one, Oscar. My name is Pablo, and my question is for all these, is there a resource or somewhere where we can find examples like this one that you've just presented? Like, is there a resource center or somewhere where we can find equivalent ones? Like, by the way, it was great. I think it was great to see how you did this.
Sure, let me show you. I don't know if this is going to be exactly what you're looking for, but let me see if I can share really quick. Here we go. So if you go to ai.google.dev/Gemma, it's going to take you to this page over here. And then if you go under docs, maybe it's a little too small, let me make it a little bigger. Under docs, on the left-hand side, you have this menu. If you scroll down, we have all kinds of guides and collabs that you can see, and more documentation on how Gemma works. We have tuning guides. This is exactly what I mentioned earlier, that you can actually tune Gemma using LoRa if you want to do something like for your grammar-free languages. You can do your fine-tuned version of it. You have application guides, how you can do all these things, deployment guides. It is all pretty well curated, but of course, there's also a relatively big community and growing community of users of Gemma and other open models that are actually some pretty amazing guides and pretty amazing stuff. So only a half answer. So this will be our version of centralized resources, but it is relatively limited compared to what I have seen the community do.
Yeah, this is great. Thank you.
Thank you.
Well, thank you for the great presentation. I really enjoyed that. Demo was excellent.
Thank you. Happy to hear. Like I said, this is not directly relevant to some of the more hardcore science talks that I think you guys are used to. But I'm hoping to just kind of get, this is more of an inspiration for how I think some of these AI models can be leveraged in a what I think is relatively simple way. And again, you can feel how extremely powerful they are with such a simple application. If we could do this for machine translation, I want you to think about, within your specific field within science, what can you do and how can you leverage some of these, even the smaller models, to do some of the workflows that may actually be more relevant to you.
I have one more question, if that's okay.
Go ahead. Yeah, of course.
So would there be a use case where you can use the models or any kind of models that are there for data processing?
Depends on what you mean by data processing. What do you have in mind?
For example, something that is very common in our research is performing thematic analysis, where you have qualitative data, such as interview data, and you want to look at it and extract certain pieces, maybe of interview transcripts, and then look at how identify patterns that you can see or similar themes. Is there a process where AI can help you in doing that?
This seems to be one of the use cases where AI could actually shine at. It's just going to be a matter of crafting a prompt that succinctly and effectively guides the AI to do what you want it to do, which maybe, I don't know, maybe you want summarization, maybe you want to extract themes, maybe you already have your themes and you want to know which ones of your themes are being hit during the specific interview. The other problem you're going to have is your context window. If your interviews are very, very long, you may have to do chunking, so you can only feed one chunk at a time to the LLM. But beyond those two things, which I wouldn't call them problems, they're more just small obstacles. This seems to be like a prime use case for AI.
Oh, that sounds lovely. Thank you. And what about collecting data such as mobile data, frequency data, for example, of pedestrians on the street, where you have more quantitative data versus qualitative data, and then feed that into a database, or where you do manual processes? Can you speed up those manual processes using tasks that the AI can do instead?
So first, let me ask you, how are you doing this counting of objects in an image?
So it's not an image, it's already data that is being provided, that's available, and that's just a made up example now. I don't have a specific use case, but I was just thinking that would be maybe very helpful, because if you do a lot of processing, inputting data, cleaning the data, and doing it manually, it would be nice maybe to have those processes or tasks or activities that you always do in a repetitive fashion, and maybe automatically automate those processes. Would that be a use case?
Yes and no. When it comes to these hypothetical examples, the devil's in the details. So in some cases, like the example you gave me earlier, that was a prime use case for AI. In other cases, you can just tweak your problem just in a very small way that will make it completely infeasible for AI to be, I think, optimal for the job, or the other way around. You tweak it just a little bit, and AI sounds like the perfect fit. I think in many cases, at least with some of these new AI models, it's a matter of trying, and it's a matter of trial and error, and maybe it works, maybe it doesn't. And even if it doesn't work for one model, it may work for the next model. So on that sense, I guess it's not. I mean, part of it is scientific, right? Because that's how science works. It's a matter of you have a hypothesis and you test it, and it's a matter of trial and error. But at the same time, from an engineering standpoint, it feels a little brittle that you just try stuff and see, throw stuff against the wall and see what sticks. Doesn't seem very robust, but that's just the way we do things nowadays.
Mm-hmm. Thank you for your answer, Oscar. That was great.
Thank you. Great questions. Any other questions?
Oscar, can you just talk about like Google's like just an overview of Google? You've got PaliGemma and you've got Gemma. Like what is how are those two models positioned? Like what are the different, like why would you use one and not the other in a different circumstance?
Sure. So in this case, we have Gemma, which is the base model for all the Gemma family of models. It is a text-to-text model. So what Gemma does is it goes from a collection of instructions, we'll call it a prompt, into an output text. In this case, we're using a technique called templating. So we are templating our prompt and then just swapping a few things here and there. I guess I'm not sharing my screen anymore. I'm pointing at the template. Let me just reshare really quick. Let's see. Here we go. So here we have it's called templating. So we have our prompt that has been templated using F strings in Python. So we swap certain components of the prompt, and then we're gonna get some kind of textual output. On the other hand, PaliGemma is a vision to text model. And as a vision to text model, it takes two inputs. You start with an image and a prompt, and then the output is going to be text. So even though it's vision to text model, technically it is vision and text to text model. The latest trend that we have been seeing, and I fully expect a lot of the existing models to go that way, is called multimodal. And these are models that are actually doing multiple things at once and can accept images or text, and then it just goes through the same model. This is, for example, how Gemini works. Some of the bigger models that are currently published by Google are already doing this. I believe the latest version of Llama is also multimodal. So I do expect that trend to continue just because it's more convenient, and also because a lot of these models do share a bunch of the same core. Because at the end of the day, you still have to parse and understand that prompt, which comes in textual format. And at least in the case of PaliGemma, it is using a version of Gemma to actually understand that prompt. And then it is using a version of Gemma to actually output the text. So technically, this could have been done in one shot, right? I'm only doing OCR, and I could have done OCR and translate. But this is going to be a little bit brittle because I've already created my translate function. I've already fine-tuned it. I'm keeping it separate and keeping it into two different pieces. That's at my engineering mind. But if you want to try this, it may or may not work. It's just going to be a different set of things that you're going to be optimizing for.
Gotcha. Thanks. Any other questions from anyone before we wrap? By the way, I did get permission from the Gemma team to share that Gemma 3 is coming sometime probably in March, or in the next few months, and it will be a multimodal version, longer context windows, more sizes. So expect a big uplift in the capability of Gemma with Gemma 3 coming soon.
Okay, well, since Scott got permission to share that, then let me add to that if when that becomes true, we will only need a single model to be able to do everything that I just did in this collab. So instead of having two models, to have a single model. What that means is that now your memory requirements will be cut in half, because right now I have to load two models side by side. If this is a single model, I can actually use a lot less memory and keep everything in memory at the same time. That is very exciting stuff, being able to have a multi-model version of some of these open models. So I think that's a great move by the Gemma team.
Kunal? I think you should be able to just come off mute, Kunal. Okay, cool.
Could you tell us more about the vision action models? Sorry, I am not familiar with RT2.
Cool. I think we can wrap there then. There's no other questions. Thanks so much, Oscar. Yeah, like we said, watch this space another couple of months for some big announcements on Gemma 3. Thanks all.
Thank you, everyone.
Yes, thank you.
Thank you.